Section 9.2. On section 9.1, we find the difference of proportion. Here we're trying to find difference of mean value. So on 9.2, we are talking about two samples are independent, and then on the next section, 9.3, two samples are dependent. So what is independent? Two samples are independent if sample value from one population are not related to somehow naturally per match with the same value from the other populations. Two samples are dependent, or they call it match pairs, if sample value are somehow match, where the matching is based on some inherent relationship. And that's something we need to discuss on 9.3. And then they have some examples here for you. You know, what's the difference between independent samples and dependent samples? You see in the independent samples, they are talking about two different groups. One group is men, one group is women. And here are talking about two groups that are related or dependent samples. Now, here we discuss about these examples. This example, 9.3, it's listed below are a student course evaluation score for courses taught by female professors and male professors. So these are independent. Use 5% significance level. So alpha is 5% significance level, that two samples are from population with the same mean. So they are claiming that mean are the same. And then they want us to also find the confidence interval. So here, first, we have the conditions. Condition is the value of the two population standard deviation are not known, so we are not making any assumption they are equal. Two samples are independent. Two samples are independent because the female professor and male professor are not matched or paired in any way. Samples are random samples. Both samples are small, 30 or fewer. So we need to determine whether both samples are from population having normal distribution. Remember, the samples has to be greater than 30, but if it's not, we have to have the quantile plot to make sure that samples are from population. So in this case, they are. So we continue with the problems. Claim. Claim is that HO is mean 1 is equal to mean 2, or the difference is 0. H1 is they are not equal. Okay, so that's H1 and HO. Now, the formula is that, and all these numbers are given. In the problems, we have X1, S1, and 1. S1 and X1, this is sample mean. This is standard deviation of the sample for the first population, sample mean for the second, and standard deviation for the second one. So we find all this. And then, again, anytime you have equal or not equal, is two tails. Alpha is 0.05, so we need to take that 0.05 and divide it by 2. So area of each tail is 0.025. And here in this section, we are discussing about the T, not Z anymore. So for the T, we are dealing with DF and also for area in two tails. Now, DF, since we are dealing with two population, we always have two N value. We take the one that is smaller. So here, DF for the first one is 12 minus 1 is 11 for the females, and for males is 14. We always use the smaller one. That's just the rule. So we put that 11 here. Okay, so there are 14 and 11. We take the 11, 5%. That gives us this 2.201. So where does this minus 0.6 fall? It doesn't fall into the critical area. It falls into the blank area or good area. So we accept HO and reject H1. P-value also from the calculator, I'll show you later on how to find it, is 0.5172, which is greater than 5%. And also to find these numbers, 2.21, here how to use the calculator. If you want to use the calculator on second verse is inverse T, then you always put area of the one tail, which is 0.025. The DF is 11. You should get that number here. And then confidence interval for the mean is this formula. Again, you have all this. E, what is E? T, standard deviation of the first population, the second population, N1, N2. You have all the numbers, you plug in, that give you the E, and the difference of the mean. So we are 95% confident that the limit of minus 0.53 and 0.27 actually do contain the difference between the two populations because the limit contains 0. Okay, see, our argue was that mean 1 minus mean 2 is 0, right? And here, if minus 0.55 on the number line is here, and 0.30 is here, so 0 definitely fall within the limit. Now on the second part, I want to show you how to use a calculator to do the problems like that, okay? So for that, here, it said first, to find the t value, first use the t-test and press enter. Okay, so we go ahead and use the test and the t-test. So it would be 2 sample t-test. I don't think so. This is a here. Two sample t-test. And you input this information. You put X1, S1, N1, you have all this, and this is mean 1. Pooled or not means you pull the information from that. We don't need that. Calculations. So that give you minus the t is minus 0.62. Almost close to this one. Okay. And the p-value is 0.53, which here we have 0.5, almost 0.52 for the p-value. And here is 0.54 or 0.54. So these are the numbers. Then the second part, to find the confidence interval, go to sample t interval. Capita already has your numbers because you use it for the t-value. And confidence level is 0.95 because there's 2 tails. Table 8.1, 2 tails, and alpha is 0.05. Calculate. So that gives you these 2 values. And disregard this DF that calculator is doing it because our DF was between 11 and 13. We decided the lower one. So that's not a part of the calculation. So that gives you the t-interval. Okay. And then I'll put some other examples that are very similar to what you have here. Okay. That would be 9.2.